All right, hello, welcome. In this video, I'm going to be working linear algebra homework 2.2, and so it's like some introductory linear transform examples. Okay, so the first one is talking about a function f, which takes Ra into Rb. And it's going to be a linear transform that's defined by matrix multiplication. So what they're telling me is that f of x is equal to m times x, where m is a 3x4 matrix. Okay, so it's in R 3x4. Okay, and so I think the easiest way is to actually draw a picture, especially at where y'all are at this point. So I'm going to draw m, a 3x4 matrix, 3 rows, 4 columns. And then I think about x, okay? What kind of x's I can put into this function? Well, that's my domain. That's going to be the value of a. And so if I think about this matrix multiplication needs to be defined, I need to have 4 rows here. So I'm going to say, okay, 4 spots there. Okay, so now I know m is taking, f is taking in a 4-dimensional vector. So a equals 4. And then it's going to give us back, well, if we think about m times x, m is a 3x4, x is going to be a 4x1, so we're going to be left with a 3x1 vector at the end. So that means that the output is a 3x1 vector. Okay, so that set of all outputs lives in R3. So the codomain's R3. Okay, that's all for that one. Okay, now number 2 is going to keep going up against this same matrix that I might copy onto a sheet of paper so I can use it more than once. Except it's kind of a big sheet, but it'll be all right. Okay, 1, 2, -3. -1, 1, 1. Wait, 2 negatives, 1 positive. And -1, 1, -3. That's A. If I want to find t of, okay, and then, pardon me, this is equal to A, t of x is equal to a times x, and okay, that's all the information that's given. Part A is like, okay, hey, find t of 1, 1, 1. But that should be easy enough. Okay, t of 1, 1, 1 is going to be a times 1.111, not 1.1. So I'm going to multiplied by 1, 1, 1, and we know how to do matrix multiplication. That's going to be 1 minus 1 is 0, minus 1 is -1. Okay, then I'll move it down, and my result will move down 1. 2 minus 1 is 1, plus 2. Wait. 2, 1, 2. Okay. And then -3, -2, -5. Okay, that's easy enough. We just do the matrix multiplication, right? Okay, that was 2a. Pardon me, people that are scrolling through the video did not do a good job of clearly identifying that I'm working number 2 here. Okay, hopefully they see that now. All right, that's going to be 2a, right? Just run the vector through the function, which is just matrix multiplication. Okay, describe the solutions to the equation t of x equals 0. Okay, so t of x equals 0. What we're going to do is we're going to augment this matrix A with 0 and row reduce, right? Because that's the same thing as solving a system, right? Solving the matrix equation. So I'm going to go over here, 1, 2, -3, -1, -1, 1, -1, 1, 3, augment with some zeros, and now we will get to row reducing. Okay, I'm going to get that out of the way for now. Okay, so this is 2b. Okay, now I'm going to row reduce this thing, and I'm going to use that 1 to clear out this. So I'm going to do row 2 minus 2 row 1s, and I'll copy that in. And I'm putting, okay, so this is not going to change. If I subtract here, 2 minus 2 is 0, -1 plus 2 is +1, 1 plus 2 is 3. And then I'm going to add 3 of row 1 to row 3. So row 3 plus 3 of row 1. Okay, so -3 plus 3, that's 0. 1 minus 3 is negative 2. 3 plus, wait a second, I feel like I've done something wrong here. Plus negative 3, that's going to be 0. I thought this was going to be, what am I missing here? Let me pause. I think this was supposed to come back with a row of zeros. All right, I see what I did. I did not copy the matrix right. Okay, I lost this negative here, which really is only going to impact this spot right here. But if I have negative 3 and I add 3 negative 1s, that's going to end up being negative 6. Yeah, I knew this was supposed to come back a different way. Okay, that is going to impact my answer for 2A, but okay, you probably noticed that I copied the matrix down wrong. Doesn't change the nature of the problem. We're just going to do matrix multiplication. I think it would just impact the last entry of my result. T of 1, 1, 1 is going to be negative 1, 2, and something not negative 5. Okay, that's all I'm going to say about it. I'm not going to go back and fix it or anything. Okay, now I'm going to take this one and I'm going to just take it. Oh, now I'm going to take it all the way. So 1, 0, 0. Nothing's going to change there. I'm going to add 2 of this row to that row. And so I'll get, and maybe I'll add it back up here. So I'm going to add row 1 plus row 2. Okay. Over here, it's just always going to be zeros because it's just lots of combinations of zeros, right? When I did row 2 minus 2 row 1s, well, I've just, took 0 minus 2 zeros. And so this is always going to be 0 to the right side. And you'll grow to recognize that when you go and slap on the 0 vector and row reduce, that it's always going to be 0. Okay. And we'll do plenty more of that in this class, so I'm not going to waste a whole bunch of time on that. And then we get all zeros. Okay, this is fully reduced. There's nothing else I could do, right? If I wanted to try to reduce on that, I would end up muddying these or those, right? I've got all of it's as reduced as I can get it. So I'm going to say, all right, if t of x equals 0, then x1 plus 2x3 needs to equal 0, and x2 plus 3x3 needs to equal 0. Now, this isn't something I'd say that's probably far enough at the point you are in linear algebra. But we're heading to a place where we're going to solve for x1 and x2. Wait, no, that's an x3, pardon me. And x3 can be whatever it wants. Okay, so we get all of the vectors of the form negative 2, negative 3, 1 multiplied by some number x3. Okay, so any multiple of this vector, if we run it through t of x, we're going to get back the 0 vector. Lots more we have to say about the geometry of that scenario right there. Okay, but that'll be all for now. In part C, we need to find the solutions to t of x equals b1, b2, and b3 to find the actual range of t, right? In the Algebra 2 sense, the actual outputs of the function. And this can be a little bit much, but having already row reduced this thing once and knowing how it's supposed to end, it should keep it from being too difficult. So this is going to be to part C. I'm going to carefully copy the matrix and hopefully not make a copy error this time. Negative 1, negative 1, 1, negative 1, 1, negative 3. Okay, and if we want to find all of the solutions to t of x equals b1, b2, b3, then we're going to augment with b1, b2, b3. And in this one, I'm not going to actually write out the row operations because you'll actually probably be able to follow the row operations on this column. And if you don't see why that's the case, then just keep watching and you will see. Okay, I'm going to do row 2 minus 2 row 1s. Okay, so that ends up being a 1, and that ends up being a 3, right? Row 2 minus 2 row 1s. Okay, and then this is going to stay the same. Okay, and then I'm going to take row 3 and I'm going to add 3 of row 1. So row 3 plus 3 of row 1. Okay, and that's going to be 0 plus 3, that'd be negative 2, and this will be negative 6. Okay, and then the same thing's going to happen. I'm going to add 2 of row 2 down to row 3, except now this thing's going to get a little heavier. That's all right. Okay, I've got this 1 and 3. When I add 2 of them down, I know that it's going to kill off that whole row. or at least before the vertical bar. And then I'll have this, but what I did was I added 2 of row 2. So I got to add 2 of this. Okay. And then, okay, I guess for good form, I will, take this thing all the way down, add this back, and that would be a 2. Okay, so B1 plus B2 minus 2B1, but we don't actually need that, is what you're going to see in a second. And then I'm going to have B2 minus 2B1. That's great. Okay, we've computed the range the old way. Okay, I'm going to show you a much faster way to compute the range of this once we understand the idea of a basis that will make this whole process seem, I won't say pointless, but really annoying, right? You're not going to want to go through this forever. What I am really trying to point out to you right here, I don't have a highlighter available to me, but it's all right, is this. The row of all zeros. Because we're kind of, right now, we're kind of precariously balancing between infinitely many solutions and no solutions, right? If we have 0, 0, 0, 0, then this is going to have infinitely many solutions. If this is not 0, then we have no solution. And we want to find all of the solutions to t of x equals b1, b2, b3. And that's telling me, okay, we're not interested in the no solution situation, right? And so to describe the possible outputs, we need there to be a solution. So if there's going to be a solution, then this thing over here needs to equal 0. Okay. So what I'm going to do is I'm going to clean all of this up, and I'm going to say, all right, we're going to have, what is it? 3 minus 4 is negative 1 B1s, 2 B2s, and a B3. That needs to equal 0. Okay. What this is going to be, basically, is this is going to be a plane, right? Because this is a linear equation, 3 variables. This is very similar to the plane negative x plus 2y plus z equals 0. But we'll have so much time to talk about the range of a matrix and the range of a linear transform defined by matrix multiplication. I'm just going to kind of leave it at this for now. But this is really B and C are both a preview of what we're going to be doing a lot in this class, and just minus the geometry part. Okay. Now, number 3, this one will be good. This will be a good one for us to end on. This is not going to take that long. Is we have A being this matrix that I copied while it was paused, but 1, 2, negative 3, 1. Negative 1, negative 1, 5, 0. And 3, 5, negative 10, and 4. Okay, that's A, and we want to solve, we want to solve AX equals B, AX equals C, and AX equals D, but there's that simultaneously word lingering in there. It's like, what does that mean? But if we were going to solve AX equals B, we would slap on B, we'd augment A with B and row reduce, right? That's how we solve those systems. Then, if we wanted to solve AX equals C, we'd do the exact same thing. But what we saw with that other matrix that we kept row reducing is that it plays out the same way each time to the left of the vertical bar. So what I'm going to do is I'm going to augment with all 3, row reduce carefully, and then I'll have all 3 solutions just like attached to my matrix. Because the set of steps to row reduce the left side is not going to change when I change what I'm going to augment A with, basically. All right, so I'm going to augment A with, what is it? B, C, and D. Okay. And then I'm going to row reduce it until I get it fully reduced, and hopefully I end up with, what's it going to be? I'm saying, the magic X where AX equals B. Call that XB. Something, so there's, some stuff on the left side augmented with XB, XC, and XD. That's what we're going for. So to do that, I'm going to just kind of, why waste the time? Right, we're going to turn this edge of a matrix into a vertical line. And then we're going to augment it with the 3 vectors. So b is -5, -17, 19, and 24. Okay. 5, 11, -12, 8. And 1, 2, -1, 5. Okay, I would love to just run this one through a computer or technology or something, but you know, y'all need the row reduction practice right now, so I'll do it right there with you. So I'm going to take row 2 and subtract 2 of row 1. Row 2 minus 2 row 1s. Row 2 minus 2 row 1s. Row 2 minus 2 row 1s. Okay, so that would be -17 plus 10 is -7. Row 2 plus 2 row 1s. Row 2 plus 2 row 1s. Okay, row 3, I'm going to add 3 row 1s. Row 3 plus 3 row 1s. Add 3 row 1s. Add 3 row 1s. Wait. Hold on. Add 9 to -10, and I get -1. Right? Add 3 row 1s. So 19 minus 15, -12 plus 15, -1 plus 3. Then down here, I'm going to subtract row 1. So 1 minus 1, 0 minus -1, 4 minus 3. Okay, what's going to happen over here? Okay, I'm subtracting the top row. So 20 minus -5, 8 minus 5, 5 minus 1. Okay. I've cleared up the first column. Just need to do 2 more columns. And so I think what I'm going to do, it doesn't really matter. I think I'm going to use this as my tool to clear out this and these 2. Not going to change. I'm going to add up row 1 plus row 2. Row 1 plus row 2, that's going to be -12. Row 1 plus row 2, row 1 plus row 2. Okay. This I'm not changing, because I'm using that as my tool to clear out the second column. Okay, I'm going to subtract 2 of these here. So -1 plus 2 is going to be 1. Subtract 2, so 4 plus 14. Subtract 2. 3 minus 42. I don't like this. This feels like possible arithmetic error, but we've gone too far, right? So subtracting 2, 2 minus 8. Okay, I'm really not sure about that one, but we'll find out. And I'll show you how you can find out at the very end of the video, right? So, and then I'm going to just subtract row 4 minus row 1. 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 Row 4 minus, or row 2, pardon me. You know. Okay, now I'm going to use this as my tool. That's not a good sign. I need to subtract 2 of these. Oh boy. All right, I think, again, it's hard when I'm not writing my row operations down. I'm having doubts about actually the 18 above the 32, but even still, this is going to play out, you know, the same. You can see what I'm going to do. I'm going to take this tool down here, and I'm going to use it to clear out the other ones, and then I'll be able to see my solutions there. But I will, if you want to talk to me more about this problem, bring it to me before school or in class or something, because there's a lot more I could say about this one. For now, I wish that it had been a 4x4, actually, that was a little easier to reduce. I'm not super loving this problem, but in the interest of being able to move forward and record for the 2-3 solutions, I'm going to stop here for this video. Thanks for watching. Again, if you need more on number 3, just come talk to me before school or being in class or something. I can tell you way more about this problem. Thanks.